In this video, we're going to be using Scan Spray and the Revopoint Miraco to scan this car fender, so stay tuned. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to be taking a look at Scan Spray and how that's going to affect our overall scanning process. For this example, we are once again going to scan my Starion Fender. It's the car that I have in here. It's easy for me to get to, and there are still marker dots and things all over it. So this is going to be our baseline, but it's a good test because of the hardware features. And for this example, I removed the marker light. I took the wheel out so we can scan inside the wheel arch just a little bit. Things that generally skip over because they're not needed for what we're doing. But in this case, I want to get as much detail as possible without going through the process of taking the bumper off. So that's a little bit more involved. I didn't really want to do it for this video. But the main focus of this is going to be the Scan Spray and also the settings that we need for the Revopoint Miraco. So first off, Scan Spray, what is it? Well, when we're scanning something like a car, the shiny surfaces are generally bad for 3D scanners. It depends on the scanner type, obviously, but if you're dealing with an IR structured light or a structured light scanner, generally they don't like these reflective surfaces. Laser scanners can get around them a little bit if it's a specific scanner that's meant for this, but in general, shiny surfaces are bad for most types of 3D scanners. So in this case, the paint's kind of old and it's not that shiny, but what I did was I sort of cleaned it up and buffed it up a little bit, so it's quite a bit shinier than it was before. Before I sort of left it dusty and dirty, made it a little bit easier to scan. I have scanned this with and without marker dots, also used a sort of a DIY option, which is baby powder and isopropyl alcohol. Perfectly fine. It's a bit messier than Scan Spray. Another thing that you can use is a weld inspection spray, but you do have to keep in mind that the carrier for those is acetone, and acetone on a painted surface that you care about could be bad. It could start to eat away at the clear coat. I actually did use acetone to clean this, and it started to eat away at the sticker because there's no clear coat over those. So again, something to keep in mind. This Scan Spray from Attblime, not sponsored at all by this. This just happened to be what I could find available. This can was about $12, and it's considered a permanent scan spray. And what that means is after you spray it on, you actually physically need to clean it off. So you'll need to go back and wash the vehicle, or if you take a wet rag, you can sort of brush it off. It ends up just being a white powder. It comes off pretty easily, but it can be messy, especially if you spray it all over the place. This fender is rusted on the bottom. I've got primer on the hood. Not really a big deal for me in terms of getting it to be a bit messy. The entire engine bay is black, so I do want to avoid spraying it all in there because it's a bit of harder to clean out. But again, if it gets in there, not a huge deal. So this being a permanent spray means that you have to clean it off. But Attblime and other companies like ASUB offer different scan sprays that will actually evaporate and dissolve, so there's no cleaning. You have to keep in mind that there's quite a steep price for that. So again, this is about $12, which is probably the lower end of what you're going to find for a scan spray like this, even just a permanent one. When you go up into, let's say, the ASUB ones that dissolve within 1 to 2 hours, you're talking about $40 a can. Now, this one can would probably do a good portion of the car. If you were scanning just the side of it and you were going to mirror it to the other side, you could probably do a whole car with this. You don't need to coat it like you're painting it, but keep in mind that that is quite a big investment to be able to do that. Marker dots also are quite an investment if you use those, and they can be kind of a pain to take off. So if you're using marker dots, you can stick them to your fingers first, a little bit of the oil from your fingertips. Before you put them on, make them easier to remove. Actually, it was quite a bit of pain to get all the marker dots off of this fender because the adhesive back stayed while the marker dot portion came off. So I had to do quite a bit of cleaning to get that off. Not something that you really want to do, and they're all over the hood, the roof, the door, the fenders on this car. So again, not something that you look forward to. If you can get away with not using marker dots, it's always a good option. So this scan spray, again, I mentioned not at all sponsored by this, just happened to be what I could get. But so far, it's done pretty well. This is going to be the classic white, which is a little tricky on a white surface. But if you're spraying something darker, which is traditionally where you would use this, a dark shiny object, then it shows up pretty well. This will be able to see the difference between sort of the shiny surface, and then it'll just be a more flat surface. This can does come with two different nozzles. So there's a round nozzle, which they say is for more detailed spray, and there's an oval nozzle. And basically what you can do is you can change the way you angle the can, and it'll give you more of a line when you're spraying. So doing something big like a car fender, it's nice to go back and forth with. The other thing to consider here when we're talking about scanning a car and prepping a car is the details you actually need to see. So for example, if you were trying to recreate this fender, the mounting points inside roll up and inside the lip. So those can be kind of tricky. It can be helpful to remove some of the hardware if that's helpful to get the hole locations. I left all the bolts in, and I'm just going to do my best to scan where those are. The hood prop is actually quite in the way because it goes right over one of the other bolts in the front. So that's going to be tricky to get to. And this fender actually has some hardware behind the bumper. So if I was trying to do a true sort of reverse engineering on this, then I would need to remove a couple more things. I need to take the pop-up headlight out, and the air dam and the bumper would need to come off. Again, it kind of depends on what you're doing. If you're making an over fender or you're designing parts to fit on this without removing all that, perfectly fine. I do like to scan it with the hood up in this instance because the fender rolls down and it comes over, and just makes it a little bit easier to try to get some of those details where the flange is and where all that information is. So with that said, let's talk about the prep. So really, there's not much prep, but you do want to make sure it's clean. Anytime you have any bumps or deformities, those are going to shine through. So keep in mind, the smoother or cleaner that you can get the surface, the better. There are some spots on this fender where these are almost like MIG welding splatter marks. Don't even know when that happened, but again, this fender is pretty rusted underneath, which thankfully you can't see down there. But I knew that the fender was going to need quite a bit of repair anyway, so I'm not too worried about those bumps there. Again, behind the bumper, not really worried about getting there because I didn't want to take the whole front end apart. But everything is clean and ready to go. Any details of trim or things that you want to pull off, make sure you get those off. This car does have a dent right here, and in reality, if you wanted a smooth base, you could go ahead and prep that. Not a big deal. Again, if we're redesigning a fender, we can look past those little imperfections. As far as spraying, I covered up the brakes here. You don't necessarily have to do that. I'm not even sure if you can see that in the frame, but if you want to just keep some of this off of the brakes, then you can do that. Another thing that kind of helps is the bag works as somewhat of a marker. So as we're scanning, as we begin to scan, the bag will show up just based on its texture, and it will kind of help be a marker for keeping tracking on the fender. We're going to be using a far away scan because we don't need super fine detail for something like this. So as we move around, some of the suspension details will help us with tracking. So now to get started, all we really do is just treat it like spray paint, but we don't put it on super heavy. So shake it up and just get started. It's going to go on wet. You're not really going to notice anything, especially because this is a white vehicle. But as the wetness starts to evaporate, then it'll leave behind the powder. So just want to work back and forth. And again, it doesn't have to be super heavy, but make sure that you do get the details you want. So if you want to get inside this area here, one thing that you're going to find is different materials and textures will actually react and behave a little bit different. So things like the soft plastic and the black plastic here, if we're trying to scan those, might need a little bit heavier coat of this stuff than we will on the painted surface. And at this point, what you probably want to do is move around and see if there are any shiny spots. Again, You really don't need to coat it super heavy. I probably put more on than I needed to, hoping that we would capture it in the camera. But just kind of take a look and see if there's anything shiny. Let me do up here as well. This car is going to be quite a mess. Now, if the car's outside and you can hose it off like you would just doing a regular car washing, the cleanup is pretty easy. If we're in here and we're wiping it down, if you're in a garage, if the vehicle hasn't moved in a while, like this one, then it is a bit trickier. Also keep in mind, you probably want to do this in a ventilated area. So make sure that you do have some space to work. All right, so now that everything is dry, we can start to begin scanning. Now, a couple of things here. Of course, we're going to be using the Revopoint Miraco 3D scanner, and I actually have a couple of different videos that we're going to be doing with this. We'll look at a rim, which has been requested, and some other parts with smaller details. So we will be doing those, but this first video, I want to focus on the car fender, because this is by far the most common question that I get from people through emails and comments, is how to get a good scan. So we're going to walk through the different settings. We're going to do 2 scans of the fender with 2 different settings so we can look at the results. There are updates that happen with these. I know that these aren't in consumers' hands yet, but as that happens, you will probably notice some different settings. So even just today on an update, it unlocked a couple of different settings. So we'll talk about those, but first let me go ahead and get the screen recording going. So when we're thinking about scanning a car, we have to think about, one, the scanner that we have access to, because that is going to ultimately affect our decisions on things like marker dots or scanner spray, or whether or not we put little pieces of tape or something to help us here. The other thing that we need to consider is what we want to get out of the scan. Now, in this case, I took the marker light out. I did not really feel like taking the air dam and the bumper and stuff off. But if we were trying to get a true depiction of this fender, then I would probably take it completely off the car. It's going to be the best way to get all of the details and features. Here, the hood prop, which it's an old car, that's how they did it, it's going to kind of be in the way. So it's going to be hard for us to get some of these details. And the pop-up headlight's still on. So there's other things that are going to be in the way. But for the purposes of this video, what we want to focus on is getting a good, clean, high resolution scan, and we're going to try to scan up into the arch and make sure that we get all this detail over here as well. So that's going to be the important thing. This is going to get kind of hacked away probably, because scanning down into the crease there doesn't work very well with most scanners. And just overall, I think that'll give us a good idea of how this is going to work. Now, whenever we're doing a scan, I'm going to come over to this side. Whenever we're doing a scan with a scan spray, whether it's the stuff that we have here, the Attblime that's white, or if you're using a different color, it's always important to check the exposure. Now, some scan settings within the Revopoint lineup will actually override the auto exposure, and you'll need to use manual exposure. So make sure you double check the depth camera in the upper left. If you're using something like an Inspire or a Range, and you're viewing this either mirrored to a phone, or if you're viewing this on a laptop, then just make sure that you double check whether or not that auto is crossed out. That's going to be important, because if it is, you want to make sure that the exposure here doesn't show a bunch of red. The blue areas are underexposed, the red areas are overexposed, so you need to kind of play around with it. This will change depending on how close or how far you are away from the object. So if we're using a far mode and we're starting to see that we've got some red here, probably means that we need to go down to a 1 for the exposure, and then just play around with it. As we get a little bit closer, we're in the excellent range, and we can just start to see some of that overexposure here on the corner. And what this means is when it scans, if it's overexposed, the points that we're going to capture are going to be floating above the surface. Generally, it means that it can't actually gauge the distance away from the scanner as well. And same thing with it underexposed, but it's actually a little less of a problem being underexposed than overexposed. So if you see an entire red fender on your screen, that's going to be bad. The other thing that we really want to pay attention to is going to be our scanning distance. These are clipping planes, and if you go closer than 300 or further away than 1200 in this case, it's going to start clipping the scan off, which means that we're not going to be getting good data coming back into the scanner. So with all that said, The general settings that we're going to be using are high accuracy with a general object type and feature alignment. We're also going to go back and we're going to try the new update for 16 frames per second, and we're going to use that with large mode. So we're going to try out both of those, but again, keep in mind that these settings oftentimes will affect the exposure for the depth camera. So it's a good idea to do your settings first and then come back and tweak all this. We're not capturing color, so I don't really care about this camera down here, but make sure that we focus on our depth camera. With that said, the first thing that I'm going to do is start in this front corner. It has a lot of features. It'll be a good spot for me to come back to. And right now we're capturing at 13 or so frames a second. So this is an update. And earlier today when I was scanning before the update, I was getting about 9 frames a second. So it's nice that we're capturing more data. And what I want to do is I want to simply capture this corner. Anything that's green is within our current view. Anything that's blue on our preview has been previously scanned. And you kind of get an idea of whether or not the tracking is working based on how well the green and the blue align. If things start to shift, if you start to see some stuff out in space, then you want to make sure you pause. Now this is a good example. It started to capture things out of place, so I'm going to use undo and go back a couple of frames and just make sure that I don't have any sort of overlapping data. If you do, it's much harder for us to remove downstream. You can manually remove frames, but capturing it in this case, 13, 14 frames a second, we already have 400 frames. I don't really want to go through thousands of frames to clean that out. It's much quicker and easier to do it here. So I'm going to go back, find a spot where I know it'll register, and then start to move up and over. Now, something you can't see on camera is inside of the Fender, we've got a couple of unique features. There's a small hole, and that small hole will be good for tracking. So I'm hoping that it'll be able to capture everything nice and clean from here. I'm just going to move slowly. I am going to come back and try to get the inside of this, but I want to get all the way to that back section. Again, it's really hard. You want to make sure that you're focusing your attention on the depth camera in the upper left and not the view in the center. I really wish that the depth camera was front and center. That would be a nice sort of way to restructure this. Because the hood is in the way, I'm starting to have a little bit of trouble, but I really want to roll around this edge because I want to capture that. So I'm going to try to make sure that I'm a good distance. Try not to move too fast and see if we can come around this hood prop. And before we move forward, I want to pause this and just review because this can be really easy for us to mess up, and I really want to make sure that I capture that and everything looks okay. All right, so now that we got that, the next thing is to go back to an area where we know we've got a good ability to get tracking. And I'm just going to work my way around, do this little 3D scanner shuffle. And I'm going to move over, try to capture the wheel arch. Remember, focus on the depth camera. This is an area where it's really easy for any scanner to start losing tracking. So when we get to the door seam, we want to make sure that we are actually lined up with where it was previously scanned from the top down. And as long as those seams line up, that'll be good enough for me. Again, it's going to be a little tricky because of that door seam. The final scan is going to be a little tough, but I really want to get all this data underneath here. It's going to be a little too close if I go any further, but I want to capture as much as I can down here and move around. It does take some getting used to because you really want to focus on the center of the screen, and unfortunately that is not going to work very well. So now I want to move in and see if I can get around this and go up into the wheel arch. So this should allow us to capture the mounting points of the Fender. I'm going to go back a little bit, see if it can find that. Anytime that happens, actually, let's go ahead and pause. Anytime that happens, you really want to double check some of the things you've already scanned to make sure that everything still lines up properly. It can be really easy to mess that up at this stage, and I don't want to do that. So it looks okay. I'm going to come back a bit, see if it can find that. Again. So again, we're going to just move in. I'm going to try to work my way inside and try to capture those mounting points. Now, with this specific scanner, I don't know if it's true with any of the other Revopoint lineup. With this specific scanner, when we pause the scan, we can actually toggle between near and far mode. So if there's an area that we want a lot of detail, so for example, mounting points, what we can actually do is pause and make sure we have enough data or details there so that it can align, and we can continue to scan with high detail. So I'm going to come back to maybe here, see if it can find that. And it seems like it's doing okay. Just work my way inside. Pause there. All right. Now, I don't need everything inside the wheel well, but what we're looking at is we want to make sure that we don't have a big jump in the wheel arch. And it looks pretty good. There's a little bit of a spot right there. I think that's okay. And I think that this did a pretty good job of capturing everything. So to kind of show the low and high detail, I'm going to go ahead and switch to near mode and just capture a little bit of detail up here. I'm not going to do much because I don't really care about it, honestly, but we need to get to a spot where there's enough detail that it is able to figure it out. Now, that's going to be very tricky when you're going between near and far mode. This could kind of mess up the scan. Let's see if it can find it. Nope, that wasn't it. All right, so I'm going to go ahead and undo the last couple frames. Let's redo that last one. All right, the big thing that I want to make sure is that that door seam is still a door seam. And I think that all lines up. All right, so I'm going to do a check mark, double check everything that we scanned. A lot of that noise is going to get filtered out. I'm going to hit plus, and we're going to do this entire process again with a different setting. So that one there was using high accuracy with the general object type. We're going to go to 16 frames a second, which with large. I noticed that when this comes into the RevoScan software, it actually says 18 frames a second. When I did this earlier and I did a test, didn't really get any more frames per second with the scan, but we'll try it here. Again, double check your exposure. You can see now it's looking pretty dark. We're going to go to far mode. It's looking pretty dark because the clipping plane was somewhere out here. So make sure that all of our modes are set. Double check your exposure. Double check the settings didn't change. And we're going to go back down to 1 and begin capturing. So remember that 3D scanning, not just with this unit, but with any units, you really want to stay perpendicular to the surface that you're scanning. That's going to be a big thing with any scanner, is you always want to keep the scanner perpendicular to whatever you're scanning if possible. The reason for that is because this is IR and IR structured light, so we can't see it with the visible eye, but it's projecting onto our surface. It's got a grid pattern or parallel lines or something like that. And what ends up happening, we can kind of see it in the preview on the screen. What ends up happening is the further away from perpendicular we get, the more distorted those lines are going to be, and it's not going to be able to capture and actually bring back information to know where it is. So as we get further away from that perpendicular reference, and as we get too far or too close, or we get overexposed or underexposed, all of these things are going to start affecting our scans. So this one, just going to kind of work underneath here. Remember, we're doing the sort of the higher frame rate. And as we come back up, I can instantly notice a problem. So I've got a couple of door seams here. So one of those door seams is way too close, which means that it lost its tracking. But we've already got over 800 frames. So I need to go back until that extra door seam appeared. Now, even though it looks like a door seam, it's possible that it wasn't. Sometimes what ends up happening is because of the projection of those lines, and if we move too fast, it'll actually skip a section. So let's just go back, see if it can find this. I'm going to move over, capture that. I'm going to go up and over and just work my way this way. So again, another thing that we notice what's happening here is the pop-up headlight is in a different location. And part of that is because there is a fairly consistent bolt spacing up here. It's about every foot. And what ends up happening is because this section is consistent and the height of that flange and the distance of the bolts and all that stuff is fairly consistent, it's easy for it to lose tracking. And these are the kinds of things when we're scanning we need to pay close attention to. So we need to back up until we are to the point where we don't have that duplication. So you need to pay close attention to the scan of the wheel arch, and you need to pay close attention to reference features like the pop-up headlights, something like that. I'm going to come back to the corner where I know that I've got a good reference. It'll be able to find that pretty easy. And then we'll move over this way. I'm going to come up and over. I'm going to come this direction. And see, now you can see it's kind of drifting away. So again, same thing happens. And it seems like with this 16 frames a second, it's capturing the data so fast and very quickly it can lose tracking. So it seems like something like this might work better if I had some additional features, things like pieces of tape or tissue or something on here that it could track and use as a reference, because everything is so straight and so similar as we move our way around, it just is kind of getting lost. So what I'm going to do with this is I'm just going to accept it as is. I've got some data there, nothing I really need to worry too much about, but I'm going to add another one using the same settings, and I'm going to focus my attention just on this little mud flap here. So hopefully with the 16 frames a second, we can maybe capture some detail in this area that we may have missed, and then we can merge a couple of scans together. So I'm going to come underneath. And see if we can work our way around here. Inside. The bag inside here over the brake rotor and also suspension components, those can help us in terms of having them as a reference. If I had put some additional features on there, it would work. But we can see that the wheel arch is much shorter and narrower in this last scan, which means that, again, it lost tracking. And it's really tough because it tries to pick up tracking based on this consistent arc. So it's very easy to understand why it gets lost. But really, since all I was interested in was this, I'm going to go ahead and accept that. Now, if you want to, when you're inside of the Miraco, you can go and you can take a look at each scan. You can get a good idea of what you captured. If you want to do any processing here, you can. You can always undo that. You can delete all the edits. Even if they were done in here, you can do that. I think the first scan is still the best, which was using that high detail mode, not the 16 frames per second. So it seemed like that was capturing enough data. When we look at it here, it looks noisy, but some of that stuff will automatically get pulled out when we do the fusion and the isolation. But it looks like I got enough detail inside of there that I'm probably good. We could maybe get a bit more inside the arch because some of that is going to get lost. All right, I'm going to add one more scan. This time I'm going to go back to the high resolution general object. I'm going to use the same settings. Going to make sure that we're not overexposed, and we'll start here. And first thing I want to do is kind of capture that bag and then use that to my advantage to kind of work my way around the inside. The bag white plastic is not the ideal solution, but I'm hoping that it'll give me enough. Again, try to pay close attention to the depth camera. What we're trying to do is capture those mounting points. It's a bit tricky, but let's see what we can get here. All right, let's take a look. So again, the sole purpose of this one was to get inside of the Fender. So we got those mounting tabs there. Not perfect. Stuff's probably not sprayed very well. It's kind of dark in there. Lots of cobwebs. All right. Let me see about trying to get some more in there. Let's see if it can find this. All right, so I found that. All right, go inside this way. Now this is tricky to keep a good distance away. I'm a bit too close, but not a whole lot I can do about that. All right. That looks pretty good. I'm going to try to repeat the process over here. So let's find that corner. See if it can find that. And then hopefully the bag will be a good enough tracker that we can get inside here. I'm way too close, but again, things are in the way. All right, let's see. I think that looks pretty good. I think I got a lot of good data inside there. So that one's sole focus is going to be just the inside of the fender. We've got some references for the suspension. Might help us. So we'll okay that. I think we're good to go. So now we've got a couple of scans to play with. I'm going to go ahead and take this back to the computer. That way we can do a little bit of processing. And then we can figure out which of these worked best. Now I can already tell you that the 16 frames a second just kind of lost its tracking. I don't know if it's just a matter of how quickly it's capturing the data, where the high detail is capturing a little bit slower, which means that the speed at which I moved worked a bit better. I think with a couple of extra pieces inside of here, features that would be recognizable, that would help that out. Again, it's very simplistic. It's just a flat section with a little bit of ridge on it, and there's a hole in the middle, but it can lose that fairly quickly. So I think that will probably be all we need to capture. One of the benefits here is we can always come back and add more scans, but let's go ahead and take a look and see what we got. All right, so now that we've got our data into the RevoScan software, we're going to begin processing. Now, when we first look at these scans, they are going to appear really messy. Now, part of that is based on a few things. It's going to be based on the scan quality, the number of frames we captured, and the object itself. Now, in this case, we're going to take a quick look at the raw data. So going to the More section where the three dots are next to your scan, this will let you look at each individual frame if you want. Keep in mind, anything that's done to the raw data is permanent. This is a destructive process. There's no undo or redo here. But if you do find that you've got slight misalignment, maybe there's 100 frames out of 1200 that are bad, you can always go in and either remove them completely or you can clean up areas where you've got some noise. So in this case, if I select the back corner of this section, I could get rid of some of that sort of noisy data. When the scanner is at an extreme angle to the object, this usually ends up generating points above the surface. We're not going to do any raw data edits to this. We're just going to purely take a look at what we can do with these scans. Now, the first scan was the one we did with high accuracy feature tracking. The second scan, we took a look at doing the same exact scan, but we used the what it was called 16 frames per second, but it's actually showing up as 18 here. Essentially, we're capturing the frames quicker. So we spent less time, but we still got about 1,200 frames out of it. Now, what we noticed during that process is it seemed like it was losing its tracking, and we can see that here. The door seam should be a straight line all the way through, but it makes a little bit of a jog there. And we can also see it with the hood. There's a sort of a second hood there. And again, this just instantly tells us that we've got a problem with several frames. Once again, you could go into the raw data and you can maybe remove some of those, but even in the wheel arch area, there is a sort of a double section there where it has lost its tracking and just shifted over about an inch. So that tells me that this scan data right now, that's probably trash. The next one, we just wanted to collect a little bit more in that sort of mud flap area and underneath, just in case we needed it. And that looks like it's okay. And this last one was really meant to capture the wheel well area. So we wanted all these stuff inside there. And this wasn't a cleaned, really well prepped area. I did spray a little bit inside, and we were able to get a bit more information. We can kind of see the suspension. We can kind of see where the hardware is, and the arch, it actually looks like it's the right shape. So I think that everything is pretty good there, even though the exterior, the visible part of the fender, is really bad. The inside, which is what we were trying to capture, looks pretty good. So we're going to keep that. And here's an example where I used that first and that last scan, and I merged them together and created a mesh body. So this tells me that it is at least good enough for the purposes of what we're trying to do. There's still some stuff missing, so there are some holes around where the fender bolts to the inner fender. We can kind of see that because of the shadowing or the angle that the scanner was actually at. That's not a huge deal for the purpose of the video at least, but if you were trying to capture that, you would want to go back and add a bit more to this project, and then you could merge those together if you needed to. We also can see a lot of different impressions in the sheet metal, so that inside the wheel arch is actually a metal piece. It's not plastic. And underneath where the mud flap is, that looks pretty good as well. Now, the only areas that are really problematic come from where the two scans were merged together. Now, this is a pretty common thing that happens, and I've seen some comments in like emails that have been sent where people have this issue. So I wanted to highlight it here. And we can see where those two scans were merged, and there's a pretty clear indication, a line there. So when we go through this process, we're going to spend a little time to make sure we understand how that happens and what tools we have available to us in the software to kind of mitigate that problem. But this is the end result that we're looking for, and to get started, we're going to work on that first scan, which is going to have the majority of our data. Now, as I mentioned, this looks pretty messy when we just first look at it. there is still plenty that we can do to clean this up. And the first step in that process is called fusion. Now, fusion is when we're going to be taking the raw data points, the stuff that was captured by the scanner, and we're going to be joining them together. Now, depending on your scan settings, depending on the object you scan, how many frames you have, this number here, the 0.57, will actually vary, but we're going to make it as small as possible. Now, if we take a look at the one where we scanned the wheel arch, the inside, you can see here it's 0.55. So relatively close, but it is a little bit smaller. But we're going to use advanced settings, and we're going to be merging anything that's within that 0.57 millimeters, and we're going to put that together. Now, you don't necessarily have to go this small, but we want to preserve as much detail as possible. So that's why we're using the smallest number here. So I'm going to go ahead and apply this, and I cut the section out where it was calculating. Depending on your computer, depending on the size of the scan, that could take quite a while, a couple minutes at least. But the first step in the process, it looks okay. Now that we have points generated with the fusion step, we could merge them together. But I want to go through the process of doing a little bit of work to both scans before we try to merge them together. When there's a lot of noise, and what I mean by that is bumps or points that are above the surface that we're really interested in, that can be problematic to alignment. So we're going to start with the default isolation. Anything that is under that 15% of the overall scan will be selected, and we can easily delete and remove it. So you can see here the bag over the brakes, a lot of the stuff on the fringes or the edges, the hood prop, some areas around the curved section of that fender flare. And those are going to be critical because those will have a direct impact on the quality of our scan. So you can see with just those two steps, the fusion and the isolation, this cleaned it up quite a bit. Did get rid of all the suspension in the middle, but it was just noisy data that we use for tracking, so I didn't really care about that. But we actually have a good bit of points inside of the wheel arch as well, so that could be beneficial. But we're also going to do the same process, fusion, on the last set of scans, or the last scan. So that cleans it up. We'll do the isolation as well. So just like we did before, we want to make sure that anything outside of that 15% isolation range is selected, and then the apply is actually going to delete it. So then we're going to just get rid of that and clean everything up. You can see this one's a bit noisier, but just with those couple steps, that cleaned it up nicely. You will note that because the fender scan is smaller overall, the actual size of it, it didn't include the bag over the brake rotor anyways. But we still need to do our own cleanup on both of these. So the next step for me generally is going to be to do a little bit of manual cleanup. Now this process is something that you don't often see when you see this in videos because it is very time consuming. But what we're going to do is we're going to go through and do a little bit of cleanup with just the polygon tool. Now this means removing anything that we're not interested in. Now unfortunately the back edge where the fender meets the door is not good clean points. And what I mean by that is the door I didn't clean, I didn't spray, and the graphics, the little sticker, actually caused problems, so there's missing data in that area. Again, with a little bit more time, I could have sprayed a bit more on there and I could have gotten maybe a little bit better, but for the purposes of what we're doing here, nobody besides me really needs the scan, so it doesn't really matter. So again, just using the polygon tool, you have to do a little bit of cleanup. There's not a ton to do with this because I only really scanned what I was interested in. And then we use the fusion and the isolation to get rid of a lot already. Now, you might notice that I did not use the overlap yet. Oftentimes I want to make sure that I clean up the data before I start to use a lot of these tools. And the reason for that is because the processing takes longer. The more points you have, the longer it will take. I also want to make sure that I'm careful with the select through option. Now, it can be very easy to accidentally delete a bit too much because you're not seeing what's underneath your current selection. So just take a little time, make sure that you understand the tools like the select through and invert selection if you are using the RevoScan software. So just, again, a little bit more cleanup, clean up the pop-up headlight and a little bit of the front bumper, and then rotate it a bit. All the stuff that's kind of floating out in space, not to worry about. Isolation will take care of that. We're going to rerun that a couple of times. Around the marker light area, there is kind of extra points right above the surface. Those need some manual cleanup, which is a very tricky area. So just have to be kind of careful here. I'm going to trace around the bumper. Again, as I mentioned this when we were scanning, if I really needed this fender, I would have taken the air dam and the bumper off so I could scan around that area, because we're unfortunately just cutting away a small portion of the fender because it is overlapping with the air dam or with the bumper. Now there is going to be some areas here, but we're going to run isolation, select and delete as much of that as possible. And then once that stuff is gone, we'll do some more manual cleanup. So if we zoom in here, the area around that marker light, if we rotate it, we can kind of see there are points in space. But the problem here, the reason that it's not getting picked up is because they're connected. Now the connected is probably because maybe I didn't get enough scan spray in there, so there was a reflection. Sometimes when you're scanning into a hole like that, that can also be problematic because some of the pattern, the IR structured light, is actually projecting into that dark area and not sending anything back, and it can get a little bit confused. So we just need to do some cleanup in these areas. Now the isolation detection, once you remove just a little bit, can be pretty handy, and just zoom in as far as you have to. They're showing up as brown and not blue because we're looking at the backside of the points. They're sort of inverted, but we want to just delete that and rerun isolation to clean it up. Now also note that the area where we cut away from the bumper, there is some small pieces there as well, so that needs to be cleaned up. But just take your time with this step. The better the edge quality is around your points, meaning that if it's nice and smooth, not jagged and not very noisy, the better quality your mesh will be when you get to that stage. Now, if you leave it really noisy, there will be a little bit of processing and cleanup that happens automatically, but it will really show downstream when you go to work with that mesh because the edges would just be kind of messy. They won't really be good for you to use for anything. So that looks much better. It's not perfect. Need to do just maybe a little bit more cleanup over here. Just get rid of that little corner there. And we can kind of see there's a little bit on that front edge of the fender, but I'm going to leave that. I think that'll get sort of processed out. And just do a quick review. I'm not going to do much to the inside of this one because the other scan, the scan here, this is the one where we really focused on the inside. For cleaning up this one, I'm going to speed through the process because it's exactly the same. There's really no need for you to watch this, but basically just clean up and get rid of anything you don't need, but you have to leave enough of the scan there so that it can automatically do the alignment when we're trying to merge the two scans together. So basically keeping a little bit of the outside, but again, it's critical that the edges are smooth. Anytime the edges are noisy, it's going to be problematic downstream. So this one looks pretty good. A lot of data for the mud flap, and there's actually a good bit for the arch on the inside. So just really need to fill in some of that area. So now what I want to do is I want to merge those two together. Because we've gone through that fusion process, you can merge at the mesh stage or we can merge here. And what we're going to do is just allow it to do some auto alignment. We're going to preview the alignment, which is going to reset it and go through the process of trying to do it again. And the main thing that we want to focus on with this is we want to look at a couple of areas where there is going to be a sharp transition. Now, if we look, for example, down here at where the mud flap is, or some of the transitions on the inside where the hardware are, we really want to make sure that everything seems well aligned. If it's not well aligned and we generate a model, it's going to push all those points together. We still haven't generated a mesh yet, but it's going to push the points together, and it'll be much harder for us to clean and isolate. So make sure that you spend a good bit of time rotating around, making sure that everything does look pretty good. We can see that it looks pretty good, so I'm going to generate the model and merge these together. Keeping in mind, these are still points. Even though we're merging them together, what we're doing is we're actually generating a new point cloud that's a combination of both of those. Now with that said, with a point cloud, we can then go on and do the isolation, the overlap, the smoothing, all the other things that we would continue to do if we were working with a single scan. So this one here is merge 02. Now, merge 02 is just the name it automatically gives it. We could rename it if we wanted to, but merge 01 was that first example that's a mesh, and this one's still points. So we want to continue to work with it. I'm going to go back to isolation, select the point cloud that we want to work with, and we want to go back through doing isolation and overlap detection. Now, isolation shouldn't pick up too much because both of them were cleaned, but you can see on the fringes some of those edge areas that did find a couple of sort of straggling points. Now, overlap is where we have to pay close attention. Remember that initially we had 0.55 and 0.57 fusion settings. And what we want to do is we want to look at overlap detection for a small number. So here, anything that is within sort of this 0.4-ish millimeter range is selected. If we move that number and we increase it to 0.6, 0.8, 1, and so on, what we want to do is we want to find any points or areas where they're sort of within that range, and we want to delete them. Now, this is where we can really get into trouble if we're not careful using overlap detection. But you can see there's still a slight hint of where the two scans are. And we could go back, we could clean up the other scans, the points, and do another merge and regenerate another model. It's perfectly possible because this is a copy of all of those points. But just play around with the overlap detection. And once you're happy with the results, then we can move on to smoothing things out. So if we take a look at these other scans, they haven't gone through the fusion process yet, so they're not available to merge. You can only merge them once they've at least been fused. So we could go back and we could make additional edits. We could continue to create other merged copies of all those points and play around with it until you have a good result. Now, I think what we have here is a good result. Could it be better? Of course. We could spend more time and we could dedicate more time to getting better scans, which means that we need to make sure that all the areas are sufficiently covered with scan spray and that we are capturing everything that we're interested in. We could spend more time cleaning them up in here. But for right now, I think we're good enough that I'm going to use some of the smoothing settings and continue to process our merged point clouds. Now with smoothing, we are going to be using a higher strength value and a lower times value. Essentially, we're allowing the points to move further, but we're not going to go through it multiple times. We're going to do it 3, 4, 5 times, and then just take a look, make sure that we're still keeping those crisp, sharp edges, and that we're cleaning up the areas where the scans overlap, those points overlap. So I think everything looks pretty good. I'm going to move to the mesh stage and kick the quality as high as it'll go. Now, in this case, it's only giving me a grid size of 1.2 millimeters. That is going to be, again, based on the points that are available in our current scan. So in some cases, you might find that number is higher or lower. It's all going to be relative to the data that's in front of it. So we're going to allow this meshing process to happen, and then we'll take a look at the results. So now when we're looking at the mesh, it looks pretty clean to start. We're going to sort of move this around and just take a look. And it doesn't appear that we have any issues with overlaps. But if we look in this one area, you can see that that does not look great. What ends up happening here is when we merge the two scans together, the 2 point clouds, there are extra points in this area. They're slightly above or slightly below the surface. And when we go from those points and we move into generating a mesh, then it ends up making all those little triangles and they're not smooth anymore. Now we can continue to run smoothing on the mesh. There will be a point at which we start to really disrupt this edge. You can already see from just the shadowing and the reflections that it's not a crisp edge anymore. It's not bad. I mean, this is probably still usable, especially if we don't need something to fit perfectly in that little corner. I think the rest of the mesh looks pretty good. But in reality, I think that we probably would be better off doing a bit more cleaning up of the points. Now, this area down here, obviously, these are multiple pieces, but it's treating them as one because that's how we scanned it. Now, in reality, that's fine for what we're doing. Probably would take everything off of the Fender if you wanted to get all these little details. So I think what I want to do is I want to go back and I want to clean those points up again. So taking a step back and cleaning the points up will give us a better merged result. And I'm going to speed through that process. So just like before, just do a little bit of cleanup with the polygon tool, remove areas that you're not interested in, isolate, merge, do a little bit of additional overlap detection and isolation, and a little bit of smoothing, make sure everything looks good, and then we can turn it into a mesh. Now, when we look at the mesh, again, the main things that we're looking at will be those areas of overlap to make sure that we didn't put a bump or a seam. Everything looks good, and make sure that the corners and edges have those crisp details that we need. It can be very easy to start over smoothing and over processing our scans, but at this point, I'm going to go ahead and export this and bring it into Fusion. Now, when we bring it into Fusion, one of the main things we note here is that the alignment is off. Now, this is one thing that you're not going to have available to you inside of the RevoScan software. There's no alignment to the coordinate system. Now, if we pay close attention, we'll see that this is actually the orientation that we started our first scan in. We're looking sort of top down from the front corner, and this is how it's aligned to the Z coordinate system when we brought it directly into Fusion. So one trick that you can do is if you're scanning a car fender, for example, start exactly looking at the side of the car if you can get to an area where you have enough detail for that tracking, and that can be your sort of base coordinate system. And what I generally do when I bring these in, if it's not a critical application, is I will start to manually rotate it. Now, this again is by no means perfect, but we want to get it to be roughly the right orientation. So I'm going to kind of do a rotation. The coordinate system, the little gnomon on the screen, changes based on how you move it. So generally I go back, select the mesh, and do move again, which is M on the keyboard. Rotate it in a specific view, in this case looking top down, and then notice that the coordinate system based on the view cube is off. Select it again, do move, and sort of rotate it around till we get to the correct orientation. And this happens a couple of times. What you can end up doing is after you get it to the correct position, you can turn off history capture and turn it back on if you're worried about having all these little features in the timeline. It's not usually that big of a deal, but you can do that if you want to. Another trick I like to use is sometimes I'll create just a basic sketch, whether it's a line or a rectangle of some sort, and then I'm going to just put this at the origin, and I'll use that as a reference for my horizontal edge. So just kind of move the fender to the right location, and then I can use the details on the fender, and I can rotate this a degree or two until it looks right. And that gives me a nice sort of horizon or horizontal line. And then from the top, I can just position it in whatever orientation I want relative to that origin as well. The sketch doesn't need to stay. It doesn't have any relationship with the mesh, so you can just use it temporarily and then delete it. And now our fender is in the correct orientation, or at least close enough for what we need to do. That brings me to the next step. We're taking a look at the small mesh elements. You can see the resolution is pretty good. We captured a lot of tiny triangles. And if we zoom in, you can see how they're built based on the OBJ export. There are a couple of really small triangles and some larger ones to give us the detail that we need. Now that kind of brings me to the next point here, is that the number of triangles will directly have an impact on your performance when you're working with it in Fusion or any CAD program. So we can see here we've got 1.75 million triangles or million facets. So that is going to be quite a lot. This can be heavy once you start to try to design. So normally I will either use direct modeling or I will make a copy of the original. When you hide it, it's not really using up very many graphical resources, but we can take this copy and then we can begin to process it, whether it's smoothing or remeshing or trying to reduce the mesh count. Now, personally, I prefer to do the smoothing when we've got the largest number of triangles, because once we start to reduce the number of triangles, then it becomes a little bit trickier because you're starting to affect those sharper edges and details that we actually want to try to preserve. Now, in this case, you can see that it is thinking quite a bit because of the number of triangles that we have. But once it's done, we can take a look, and it doesn't look drastically different. We can still see a little bit of texture there. But again, this is basically it's moving those tiny triangles up and down slightly. So you could run this a couple of times just make sure that you don't get a negative impact or influence on any harder details that you might want. That's one of the reasons why I like using this car fender, because it does have a lot of hard edges and we can definitely see if we over process. When we're doing the remesh tool, it's the only one that has our shape preservation built in, so we can preserve boundaries, we can preserve the sharp edges, and we have a slider for shape preservation and a slider for density. So it's a good idea to play around with this tool on your scans. Depending on the level of detail you need and the shapes you're working with, you can get away with a larger number for the density, and you can really have a big reduction in the overall face count. Now, what I've noticed, and sometimes when it finishes processing, it jumps back to RevoScan. I don't know why it does that. But we can see here that the results are not great. We have a lot of areas where it looks just a bit softer, like it's melted. And then we also have a bunch of bumps. But you can see that it went from 1.7 million to like 300,000. So that is a big change or a big reduction in the number of triangles. What I would do is continue to play around with this by changing those density settings, but I'm not really super happy with this result. So probably not something I would use. I would prefer just to use the 1.7 million with the higher detail, as long as I have the resources in my computer to handle that. But I think that overall, this looks like a pretty good result. There are some areas of concern. This is based on the sticker. We can still kind of see the ES there. And those are the areas where the sticker just didn't really come in very well. The back edge of the fender, because we were scanning into that door seam, didn't come in very well. So in reality, I would probably either take the fender off or maybe even just open the door so I can potentially get a better scan in there. I'm happy with the details on the inside. I know where all the bolt locations are. There is obviously some missing because the pop-up headlight was still installed. So again, depending on your needs, you might have to remove quite a bit. I would have to take the air dam, the bumper, the pop-up headlight off, and all that was just kind of cumbersome and a bit timely to remove for something that I don't truly need to perfectly reverse engineer this fender. But I think that overall, what we should take away from this process is that the initial scans looked really messy. So when we open them up in RevoScan, really anything from the range or the Inspire, even the pop, and obviously this Miraco scanner, all of that looked pretty noisy, but we still are able to clean it all up. So when you see those initial scans, make sure that you don't just instantly trash them, because there's likely still a lot of good data there. The next thing is to spend the time, if you have to merge multiple scans together, spend the time to make sure that you clean up both of those. Obviously, we're going to be cleaning up the points and getting rid of as much overlap as possible, and then going back through the process of isolation and overlap detection, and finally smoothing. And last, it's always important to remember that once you finish with it in the RevoScan software, if you're missing any data, you can always go back and add more scans. So with this project, especially since it's still on the scanner itself and it's all self-contained, I could go back to that same project and add another scan and capture some more of those details that maybe I missed. Now, if you are using Fusion 360, which is the main CAD program we cover on this channel, then bringing it into Fusion, we still have a couple of additional tricks up our sleeve to do things like smooth and process the mesh. While you don't necessarily have to, it's nice to know that we do have a couple of tools to help do a little bit more processing. Now, I might get some comments to say, well, you did a lot of sort of smoothing and all these different things to the scans. How accurate is it going to be? Well, on those large scan models, we're talking about plus or minus 0.2 millimeters. That's the claimed accuracy. When we did our Fusion settings, it was 0.57 millimeters. And then when we did our isolation and overlap detection and then turning it into a mesh, each step in that process, yeah, we're going to lose a little bit. But overall, if you're making large parts to fit onto cars, onto fenders like this, you're likely not worried about 0.5 millimeter. I think we're well within the range of the 0.2 millimeters. And I think that everything did come out pretty well. So at this point, we've been going at this for over an hour. If you have any questions on anything you've seen, please let me know. As always, thanks for watching, and we'll see you in the next one.